Hello my dear students, welcome to the class of 12th English medium. The subject is statistics, part 2, chapter 1, probability, brought to you by Vitan sir. Now, we are continuing the exercise 1.1 from the previous tutorial. In the previous tutorial, we completed 8 sums. Now the remaining 7 sums we will solve in this tutorial. Question number 9. Two numbers are selected from first 5 natural numbers. First 5 natural numbers are 1, 2, 3, 4, 5. We have to select 2 numbers. The sum of 2 selected numbers as at least 6 is denoted by event A, and sum of 2 numbers as even is denoted by event B. Write the sets showing the following answers. Okay. The first question here itself is the U, that is the sample space. So selecting 2 numbers out of first 5 natural numbers, that is 1, 2, 3, 4, 5. That would be 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, 3, 4, 3, 5 and 4, 5. This is something which we have already done in the previous tutorial. The second question here is writing down the event A, that is the total is at least 6. Now if you see the sample space here, the first event is 1, 2, the total is 3, then the total is 4, 5 and 6. So at least 6 means 6 or more. So 1, 5, total 6 we will take. 2, 3 is 5, so we will ignore that. 2, 4 is 6, 2, 5 is 7, so all the other events we will take. So 1, 5, 2, 4, 2, 5, 3, 4, 3, 5 and 4, 5. So the answer for event A is 1, 5, 2, 4, 2, 5, 3, 4, 3, 5 and 4, 5. The third question here, B, is that the total is even. Okay, the even total means it is 2, 4, 6, 8, 10, etc. The totals here, if we check, 1, 2 is 3, then 1, 3 is 4. So that we will take 1, 5 is 6, then 2, 4 is 6, 3, 4 we can't take, 3, 5 is 8. So that we will take. So 1, 3, 1, 5, 2, 4, 3, 5. Just looking at your sample space will get you the answers directly. You don't have to actually calculate much. You just have to take a look at your sample space, because nothing out of the sample space is allowed in these sums. The fourth question here is A union B. We just have to combine the events A with the event B. That's all. So I am just combining both the events in a ascending order. So 1, 3, 1, 5, 2, 4, 2, 5, 3, 4, 3, 5 and 4, 5 will be the answers of event A union B. Next question is the intersection of A and B. Now A is total at least 6 or more, B is the even number. So we know that total 6, 7, 8 and 9 are the parts of A, and the total 6 and 8 are even. So we just have to write the events with the total 6 and 8. So that would be 1, 5, 2, 4 and 3, 5. 1, 5 and 2, 4 has the total 6, 3, 5 has the total 8. That's all. So you can use brains like this also if you don't want to look at the sample space. If you want to look at the sample space, or if you want to just find out the common values between A and B, go ahead. That's also a valid method. Sixth one, A dash. Every event which is not part of A. Now A is 6 or more total, so every event which has a total less than 6. That's one way of thinking. And second option, every event which is a part of sample space but not part of A will be your answer. Okay, so either of these two options you can apply and you will get this answer here. That is 1, 2, 1, 3, 1, 4 and 2, 3. All of these events have totals less than 6. Every other event has 6 or more total. A minus B, that means take event A and remove all the elements which are the common with B. The second option of thinking is take event A and remove the intersection AB values from that. Okay, so A event we already have, and these 3 events of intersection 1, 5, 2, 4 and 3, 5. When we remove these 3 events from the original event A, we will get the answer A minus B. Okay, so 2, 5, 3, 4 and 4, 5. These are the 3 events which depicts difference event A and B. The eighth question is A dash intersection B. Now A dash we already have here 1, 2, 1, 3, 1, 4 and 2, 3. okay, and we have to find common events, intersection event of this with B. B is the even number. So if you just find out the even totals from A dash, you will get your answer. 1, 2 is 3, not available. 1, 3 is 4, okay. Yes, that's all. Only one event is there, one element is there, that is 1, 3. Okay, no other element is there, not possible. The ninth question is, are events A and B mutually exclusive? Give reason. Of course, the reason, the mutually exclusive rule states that the intersection of events should be a null or an empty set. As you can see in the fifth answer here, there is some elements in the intersection of A and B. That means this is not a mutually exclusive event because we need empty sets as their intersection, which is not here. The last question here, state the number of sample points in the sample space. Now you just need to find out the total number of elements of our sample space, which are 10 elements. Okay, so with this our question number 9 is over. We will move forward to the next question. Question number 10. 3 female and 2 male employees are working in an office. One of them is selected for training event. That selected employee is female is A and that of male is B. Find the sets showing following questions. First one. As usually, write down the sample space. So we have 3 female and 2 male employees. We are only going to select one. So that means the sample space here will be female 1, 2, 3 and male 1, 2. Okay. Second question here, that female employee is selected. So the answer will be female 1, female 2 and female 3. Third question, B, male employee is selected. That is event B, male 1, male 2. Fourth question, A union B. That means we have to add female employees with the male employees. That means A union B will be female 1, female 2, female 3, male 1, male 2. Okay, it's simple till now. The fifth sub-question asks us to find the intersection between A and B. Now, A is 3 females, B is 2 males. There is nothing which is common between these two events. That means our answer will be an empty or a null set. Sixth question asks us to find A dash intersection B. Now, A dash means everything which is not part of A. So, A dash is number of males, that is M1 and M2. So, B is also number of males, that is M1 and M2. So, A dash is M1, M2, B is also M1, M2. So, when we combine them, find their intersection, our answer is just M1 and M2. The seventh question here is, are events A and B mutually exclusive? If yes, then why? If no, then why? The question here is that as A intersection B is a null empty set, events are mutually exclusive. Yes. The eighth question here, are events A and B exhaustive? If yes, then why? If no, then why? Now let us recall, exhaustive events mean when we make a union of two events, we get the whole sample space. That means when we combine A with A with B, we get the whole sample space. And if you remember our question number 4, in that A union B was the whole sample space because F1, F2, F3, M1 and M2 was our answer. So A and B are exhaustive events. Okay, let us move on to the next question. Let us move on to question number 11, and one card is randomly drawn. These cards kind of questions are my personal favorites. One card is randomly drawn from a pack of 52 cards. If drawing a spade card is denoted by event A and drawing a card from S to 10, that is a no face card, that means no jack, queen or king, just 1 to 10, is denoted by B, then write the sets showing the following outcomes. Okay. let us get an introduction to what are the cards and the suits and colors, because this kind of questions will keep appearing, and even if you are not playing cards, knowing which type of cards are there is very important. Okay, so let us start with a pack of 52 cards. The first part of pack of 52 cards are the cards with the red color. I am talking about the color here, not particular suit. So there are two types of colors. First color is a red color and second is a black color. And there are 26 cards each of the red and the black color. Then red color has further two suits. The first suit is known as the diamond, which has 13 cards, S to king. Second red color card suit is the heart suit of 13 cards, that is again S to king. Similarly, black color cards also have two suits, that is the spades and the clubs. I have also given the symbols here so that you can remember the color, the suit with the symbol. So red color card with diamonds and hearts, black color cards with spades and club. Okay. Now the question here was, once again, if drawing a spade card is denoted by event A, that means the 13 spades cards are a part of event A, and drawing a card from S to 10. Now no particular suit is mentioned here. Which suit S to 10? That means we have to take all the four suits S to 10. That means four suits each with S to 10, S to 10 and so on. But still before that, let me show you guys a complete pack of 52 cards which looks like this. The first one is club, S to king. Now I'm showing you this here because you need to remember the face cards and the no face cards. S to 10 are known as the no face cards, and jack to king are known as the face cards. So as you can see, there are four suits. So 10 no face cards from each suits makes it 40 no face cards, and 3 face cards from each suit makes it 12 face cards. So 40 no face cards, S to 10 of 4 suits plus 12 face cards, jack to king of the 4 suits makes it a total 52 cards. So whenever you are in a doubt, just revert back to this video and in this slide. Okay, the time here is 12 minutes, so at the 12 minutes you will get this particular picture here. So you will be very clear which type of cards are there: club, spades, heart and diamonds. Now let us move on with our question. The first sub question is writing down the sample space here. Now I have written it with a trick. D means diamond, so diamond 1, 2, 3 to jack, queen and king. Then H means hearts, you know, I'm going according to the colors: diamond, heart, spades and club. H1, H2, H3 up to H jack, H queen, H king. Similarly, spades and clubs. Okay, so this is the sample space including all the 52 cards. Of course, no one is expected to write down all the 52 cards here, so just be tricky and do some smart work. The second question here is writing down A, that's the cards of space. You just need to write down the cards of space, that is S1, S2, S3 up to Sj, Sq and Sk. The third one is the B event, that is no face cards, that is S to 10 of all suits. So you just need to remove that jack, queen and king from the sample space. Okay, so D1, D2, D3 up to D10, and similarly the hearts, the spade and the clubs. Okay, so that's the event B. Remember this: A are only spades, B are only no face cards, because that will be useful. Fourth sub question, A union B, that means we need to combine the spades and or no face cards. That means we need to combine the spade cards and the no face cards together. So it will look something like this: diamond no face cards are 10, heart no face cards are H1 to H10, while spades are 1 to 10, jack, queen and king, because spade cards special event is there, and then again clubs 1 to 10. So this becomes the combination, the union of events A and B. The fifth one is the intersection of events A and B. That's cards of spades which are of no face. Okay, so we just need to find the common thing between both the events, that is cards of spades without any faces, that is S1 to S10. Simple, that's all. The sixth event here is B dash, not no face cards. Okay, B is no face cards, dash is not no face cards, that means the face cards. So cards with faces, that means in the all the four suits, diamond, jack, queen, king, hearts, jack, queen, king, spades, jack, queen, king, and the clubs, jack, queen, and king. Okay guys, I hope you like this cards video with what I explained, because this is something which you are going to have again and again. Moving on to the 12th question now. These are some easier questions here. Events A1 and A2 of a random experiment are as follows. Find the union and intersection. Okay, the A1 and A2 have been explained here. A1 is x, where x lies between 0 and 5, and x is a natural number. Now natural number is 1, 2, 3, 4, and you know the meaning, right? Actually more like it's not a natural number, it's just an integer. We can't say it's a natural number, it's an integer. Okay, so a2 lies between -1 to 3, and it is also an integer. That means we can say it's a whole number or integer, it's okay. A1, when we convert these symbols into regular numbers, it lies between 0 and 5, and it's an integer, it's a whole number. That means the actual values are 1, 2, 3, 4. There is no equal to, there is only 0 less than, not equal to, so 0 is ignored. Then x is less than 5, not equal to, so 5 is also ignored. So every integer between 0 and 5, that is 1, 2, 3, 4. Similarly for the event A2, every values between -1 and 3 will be 0, 1 and 2. We need to find their unions. So A union B, when we combine A1 and A2, we get 0, 1, 2, 3, 4, and when we find the common values here, we just get 1 and 2. Okay, so that's the answer for intersection of A and B. Next, question number 13 is again something similar. Events A1 and A2 of a random experiment are as follows, and we have to find their union and intersection. Ditto, same question, but the values have been changed. A1 is x, where x is 2 less than equal to x less than 6. Here again x is an integer. And A2 is x, where it is 3 less than x less than 9. So x is again an integer. So A1 we have to start with 2 and end before 6, that is 2, 3, 4, 5. In the A2 we can't start with 3 because equal to sign is not there. So we will start with 4 and end before 9, that is 4, 5, 6, 7 and 8. We need to find the union, that is 2, 3, 4, 5, 6, 7, 8, and the intersection, that is just 4 and 5. Okay, so these are some easy and simple sums for the breathing, you know. Now we are in the last parts of the exercise. Question number 14. The sample space U of a random experiment and its event A are defined as follows. Okay, the sample space and event is given. We need to calculate the complementary event A dash. Now the U given is x, where x is 0, 1, 2, dot, 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 10. So just looking at the numbers here, we can get that okay, it's a whole number with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And what's A is x, where x is just 2, 4 and 6. Okay, so all the events which are part of U but not part of A, that is events from 0 to 10 but without 2, 4 and 6, could be written as 0, 1, 3, 5, 7, 8, 9, 10. Okay, that was actually very simple sum. We just need to take 0 to 10 and remove 2, 4, 6, write down every other value. That way we will get the complementary event A dash of A. Next is the question 15, the last question of this exercise, a bit tricky but quite easy. The sample space U of a random experiment and its event A are defined as follows. Find complementary event A dash of A. Now you might think it's a similar sum, but looking at the picture here, U is a value between 0 and 1, and now of course there is no integer between 0 and 1, and there is not a mention that okay, it's an integer, so that means it's a real number, and between 0 and 1 it can assume any infinite values, whereas A is half less than equal to x less than 1. Okay, so U is between 0 and 1 while A is half to 1. So how to solve this sum, how to find the complementary event for this? Very simple. Actually, you can directly do this, but let me explain it in a very simple manner. Let's assume that this line here is from 0 to 1, that means it's the universe itself. Okay, this line contains all the value between 0 and 1. Okay, now event A, if I want to depict event A on this line, how can I do it? At the exact center of 0 to 1, half is there, and event A ranges from half to 1, so it can be shown like this. The event A is from half to 1. Now complementary event means all the remaining portion of the universe is my complementary event, that I am showing right now as a red highlighted box here. So as you can see, the range of this red highlighted box is from 0 to half, but as A is equal to half, A dash will not be equal to half. Okay, just remember this point. As A is equal to less than or equal to half, half was less than or equal to A dash will not be equal to half. So when I write it down, it ranges from 0 to half, and that is 0 less than x less than 1 upon 2. So that would be the complementary event for the given event A. So whenever in the future this kind of sums appear, you can just draw your universe, then draw the given event there, and the remaining portion you can find it out as your range. Okay, getting my point? So with this I end a bit longer video than usual here. Stay tuned with me, guys. Next time we will start with the definitions of probability and how actually probabilities are found. Till then, stay tuned, stay home, and stay safe.